All right, so we've looked at relations, decided how to determine if a relation is a function, and now we're going to look at function notation. Probably already seen it before, but it's just a fast way of showing functions, basically expressing functions in a little bit faster way, and it'll be used a lot more as we go through high school math. Just makes things a little bit clearer when you're doing different calculations, when you're doing modeling different situations with functions, applications that you do, that kind of thing. So let's read the introduction. Function notation is a mathematical notation that shows that one variable depends on another variable and is a useful shorthand for making statements and asking questions. You will learn how to express equations in function notation and how to interpret function notation. So here we're starting with an application question. The cost of a banquet is $200 for the hall rental plus $15 a guest. The independent variable of this relation is which. So which, think about what depends on what. So if we're talking about cost and guests, well, the cost of the rental hall depends on how many guests there are. So the independent would be the number of guests. So I sometimes abbreviate to the number symbol. And the dependent variable is the cost of the banquet. Write an equation that relates the total cost of the banquet C to n, the number of guests. So C equals, so how do we get the total cost? It's $200 no matter how many guests arrive or pay for tickets or whatever that is. So $200 plus $15 times the number of guests. Okay, so that is an equation that relates those two values. Then it says complete the following table of values and use them to sketch the graph. Label the axes. So if there are 0 guests, it's still going to cost you $200, right? If no one shows up, that's a flat rate. That happens a lot. There's a base pay, even if no one shows up. It's almost like a deposit as well, a non-refundable deposit. Then if 20 guests show up, then you want to substitute in. So basically here, C will equal 200 plus 15 times 20. You're substituting 20 in for all the n values. So what's that? 3,300 plus 200 is 500. For 40 would be 600 plus 200 is 800. For 60 would be 900 plus 200 is 1,100. So you can see here, as we increase by 20, okay, what are we doing here? So we did this in an earlier lesson. We're adding 300, right? So we could continue the pattern if this continues in the same way. So plus 20, and this will be plus 300, which is 1,400. Plus 20, that would be 1,700. And notice how it's skipped here. So you don't want to just add 300. So you want to multiply. So you want to go C equals 200 plus 15 times 200. So that's 3,000 plus 200 is 3,200. Okay. So we're going to graph these. So 0, the scale has already been done for you, which is great. Actually, on the horizontal axis, that's n is your variable, and that's the number of guests. And the variable here is cost, and that's the cost of the banquet, or just cost. And that's in dollars. Okay, the dollar symbol isn't there. So 0, 200. So each grid marking is 100, so that would be 200 there. 20 is 500. 40 is 800. 60 is 1,100. 80 is 1,400. 100 is 1,700. And then we skip to 200, which is 3,200. So about there. Okay. So is the data discrete or continuous? Well, we haven't joined them up yet. If you take a look and think about it, you can't have part of a guess. So it's discrete. Can't have part of a guess. Now, in this case, there are values in between here though. Like you can have 10 guess. So 10 would be 350. So we can actually join these up. So if I were to join this, start here. Oops, I'm a little bit off. I'll move it in a sec. Like that. So basically, so when we look closely, when we zoom in discrete points, when we zoom out, which is kind of what this is, points look connected. But really they aren't. Because you can have one guess, right? And one guess would be 215, just slightly above there. So when you zoom out like this, it looks like they're connected. Is it a function? Yep, for every number of guess, there's just one cost. So yes. So there's only one possible cost for each number of guess. Okay, so to summarize this one, to show that the cost C is a function of the number of guess n, we can rewrite the equation as, so just I put, originally I put the 200 first. Most times we put the variable term first, so it's been rearranged. And then we also, for function notation, so this is function notation, have capital C with bracket n. This is new notation, it's called function notation. So how do we read it? It's read as C of n. So C of n equals 15n plus 200. This does not mean C multiplied by n. So the brackets here do not represent multiplication. So you need to remember the context of a question or an equation or anything in math. Think about the context. In this case, if you see an equals after the C bracket n, and you see an n on the right-hand side, that means that it's function notation. So C is a function of n. In that function machine, n goes in and the cost comes out. Okay, so some more questions to do with this example. You should have determined that the cost for 60 guests is $1,100. So if you look at your chart, it is. This can be expressed as C of 60 equals 1,100. Okay, so it saves some words, right? What does C of 80 equals $1,400 mean, or 1,400 mean in the context of this application? It means the cost for 80 guests is 1,400. A lot faster to write it like that, right? So that we're trying to find some fast ways of doing things. And that's what this notation does. What does C of 250 mean? That means the cost for 250 guests. Do we know what it is? Nope, that's the next question. So use that to determine C 250. So we write it in for n everywhere in the equation. Okay, now don't have to rewrite the left side, but put equal sign underneath. Then figure out the value of that. So actually I just need my calculator, which I had out, but my computer shut down on me. Just give me a sec. Okay, so sorry, I need to clear. So 15, you can just use times rather than brackets, saves yourself a little bit, plus 200. Here, if you have a TI like this, where you see this screen, it follows the order of operations. Okay, so 3,950. Okay, so the cost is, then I do a little statement because it's an application, and I put the $sign in there. Okay. Use the equation to determine C of 70. So same thing, C bracket 70 equals 15 bracket 70 plus 200. What you might want to do, I sometimes do with a different color. I put the, actually I didn't need to do that, sorry. So I'm going to do this. I'm going to do whatever I'm substituting in a different color. If you're having trouble with simplifying this, okay, just separates it. Then you know it's 15 times 70 plus 200, okay, 1,070, and then cost is $1,007, okay. Explain how C of 70 could be determined using the graph of the function. So let's go back and look, because it wasn't a value in our table of values. So where do we look on our graph? We want to look where n is 70. So there's 70. So we want to go up to where it touches the graph and then across. So on the smart board, it's not working so well. So if I actually take a line here and go across a little bit easier, okay, so it looks like a little bit more than 1,200, okay, so let's say, oh gosh, let me just do this, sorry, time, not so, anyway, a little bit more than 1,200, I'm a little bit low on that one, so I'm going to say like 12, let's say 1,250. Okay, so we want to look at the point on the graph that has an n value of 7. So vertical line from n axis up to the graph, then horizontal line across to the c-axis, okay, which is the vertical, and it looks like to be about 1,250, okay. Okay, and then explain how to use the graph to find out how many guests were invited if the cost was 2,000. So now we know our cost value, and we want to go across to 2,000. This is a little bit easier to see here. So I'm going to try a line again, 2,000 to there, and it looks like it's exactly, now if I do a line from there, oops, I gotta move this. Then here, it looks like it goes right down to 1,200. Let's extend up. Try to extend up. Have a little difficulty but it looks like, sorry, what did I say? 120 when you go down, okay? So what did we do there? So look at the point on the graph that has a C value of 2,000. So that's a horizontal line from C axis across to the graph. Then a vertical line down to the N axis, which is the horizontal axis. Okay. So question 11 can also be asked is, what is N if Cn equals 2,000? Use the graph to answer. Determine N if, okay, so use the graph to answer. Then, determine N if Cn equals 2,600. So this, we said it was 120, okay, from our graph. Now, determine N if C of N equals 2,600. There, I'm a little bit high on that one. Goes down, so then let's see if it will let me fix it. It seems to be not liking it too much. So from there, I'm estimating a little bit in terms of, I'm a little bit high on that, so I'm going to be a little bit past 160. So I'm going to say maybe, well, I guess it's approximately right because that needs to be lower up top. So 160. You can do better with actually a ruler on your paper, but I'm going to say about 160. Okay, so this would be 160. Now the thing is, because we're estimating on there, it may not be exact. So we want a way to provide accurate answers. And that's where we're going to use the equation and work backwards. Because now we actually know that this value is 2,600. And so we want to use our solving equations from math 8, 9. So you want to subtract 200 from both sides. Okay, so that's 2,400 equals 15n. Then divide by 15. And 15's divide out, so n equals 2,400 divided by 15, and we get 160. Okay, then we know we were actually correct. We said approximately before, now we're exactly. So that means there are 160 guesses for this application. Okay, next one. So example 1 here, the height of a ball h in meters is given as a function of the time t in seconds by h of t equals 100 minus 5t squared. Graph is shown. Anytime a ball is thrown into the air and you're representing height versus time or height versus horizontal distance, it's going to look like what's called a parabola, sort of half of a U shape like this, an upside down U. So what does h of 2 equals 80 mean? It means that the height of the ball after 2 seconds is 80 meters. Okay, so you want to go, if you take a look at your graph, go up 2 seconds and across, and it's 80. Okay, so now let's use the equation to determine h of 3, and then we'll verify on our graph. So h of 3 equals 100 minus 5 times 3 squared. Have a different color. You can put it in for t in this case. So then we'll have 100 minus 9 times 5 is 45. So that's 55. Okay, so height is 55 meters. Now let's take a look. So when t is 3, let's go up and then across. It's halfway between 50 and 60, so that makes sense. Okay. Then use the graph to estimate 2.5. So 2.5 is here, so we're going to go up. It's like a little bit below the grid marking. So when I go across here, oops, it's going to be, so that's 65, I'd say about 68. Okay, 68 or 69, so let's see, say 68 meters. And then use our equation to determine it exactly. And again, you want to use red for what you're substituting in. And so that's going to be 100. 2.5 squared is 6.25 times 5. I think I'm going to do this here. So 5 times 2.5 squared, 31.25. I could have done this all in one. Okay, a fast way to get the previous answer on all TIs is second negative. Some you can cursor back up. So I could go 100 and cursor back up to that previous answer and we'll fill it in. Oops, I need to put a minus sign though. Let me do that again. 100 minus, and then that, and then I get 68.75. Okay, so that's what you do on TIs. So 68.75 meters. I said 68, so we're pretty close, right? That's why it's best to use the equation if you can. So, are they the same? Not the same, but close. Algebraic method, so using the equation, is more accurate. It's accurate. Just plain and simple, it's accurate. Graphing is a little bit off depending on the scale of the graph. So use the graph to find t if now we know the height is 20. So back up here, my height is 20. So I want to go across on that grid line, which makes it a little bit nicer, and down. That one looks to be exactly 4. Estimate the range value when the domain value is 3.5. So domain value in this case is t. So now t equals 3.5. That's up here and across. And again, that's 35. That'd be about 38, from what I can tell. You have to find t, so that would be seconds. Domain value when the range is 95. Range is your height. 95 looks to be exactly 1. Okay. Graph this function in your calculator using the same window as the graph shown above. Use your graphing calculator to verify the answers to part B, D, F, G, and H. So again, if you have your graphing calculator with you, if you don't, maybe you can, you're just going to have to follow along. These days you can't really share because you don't want to get too close to people. So graph the function in your calculator using the same window as the graph shown above. So we want to go y equals, our equation was 100 minus 5x squared. So notice how we can't change it to height and time, but height is your dependent, so that's going to be y, and time is your independent, so that's going to be x. Okay, and then same window as the graph that's shown. So let's take a look. What is our, oh, that's not what I wanted to do. Here. So when I look at the previous graph, so this goes from 0 to 5, and then you can just go up by ones. And this goes 0 to 100 and up by tens. So in our window, 0 to 5, up by ones, then 0 to 100 maximum. Actually, it goes up to 110, so I'm going to change that to 110, gives a bit of space, and it's labeled in tens. You don't need to worry about the X resolution, anything else underneath there. And then press graph. And it'll look a little wider just because your screen is rectangular the long way. Okay. So then we've done that. Then it says verify answers. So in B, so what's in B? B is when T is 3. So how you can do this, you press trace. You can cursor left and right, but you'll notice that there's a lot of decimal values. You can't get right on the X value of 3. You can get close, but to get on that X value 3, just punch in 3. Okay, it assumes when you're in trace mode that you're looking for when X is 3 and then enter on it, and X is 55. You're good. Then while you're in trace, and you know you're in trace if you see it flashing and you see your equation above. So then 2.5, enter, 68.75. We're good. Then, working backwards, what do we do when H is 20? So there is no way to, other than cursoring, so we can go down to where we're looking for Y is 20, but we won't get exactly on it, right? Really close. So what you have to do is go to Y equals and put Y equals 20, and it's going to draw a horizontal line. And you really want to find that point where Y is 20, so that's where the red line here intersects with the blue line. So we have to go second, trace, and then intersect. Okay, and then it just asks you, are you on your first curve? Just enter on that. Second curve, enter on that. Guess, isn't really not a guess, but close enough. Intersection is 420. So it gives you 4 for your time value. Okay, and then, so that's good. You can go through and check the rest. Okay, so that's checking all of those values. All right, let's take a look at example 2. The graph of Y equals G of X is shown. Use the graph to state the value of G of negative 3. So you want to look where X is negative 3. You want to look up to the graph, and it looks like the Y value is 9, which is, in this case, called G of negative 3. Okay. Next one, G of negative 1. So we look for when X is negative 1, up to the graph, your Y value is 3. Value or values of X such that G of X is 5. So that's now your Y value, right? Your vertical value. Specifically in this case, it's called G. But in general, it's called the Y value. And so if you look across at 5, there's actually 2 points, right? When you go across that way. So when X is negative 2 or 1. So just separate them with a comma, no brackets around them, because that would represent an ordered pair. These are just 2 different X values. Value or values of X such that G of X equals 9. So same thing, we go across here. There is negative 3 and positive 2. So X equals negative 3 and positive 2. All right. Next one. A golf ball is hit and its path is defined by that equation where H is the height in meters and D is the horizontal distance in meters. Use your graphing calculator to graph this function and write your graphing window in that format. State the value of H of 40. So we're doing this. Again, you can do this. Some of these questions you can do without a graphing calculator. B and, well, there's 2 B's. Anyway, both of these where you know the initial value, you can substitute it in. If you know the H value, you're going to have to work backwards, okay, algebraically. But we're going to just do this one on our calculator. So clear off what you had on there already, and then enter negative 0.004, and then instead of d, it's x squared plus 0.4x, okay? And window setting, it says write your graphing window in that format. So our graphing window from before, if I use what we had from the last question, we don't really see very much. See how it's blue on the bottom there? So we need to think about this window, okay? Here, got a golf ball, okay, and your x value is the horizontal distance. Maybe for me, the maximum will be 5 meters, but like a golf grease, sometimes it's like 150 meters or something like that. So I'm going to go from 0 to 150 for right now, just to check it out. And scale doesn't really matter. It'll just look thicker because it'll be trying to do a mark. But in this case, why don't you make it like going up by tens? And then minimum 0 for the height. And then thinking about a golf ball going in the air, maybe 30 meters in the air might be the max. And then you could just go up by maybe 2s. Leave the rest the same. Graph it. And you notice it doesn't fill up my whole screen. So 30 meters is pretty high. And also the golf ball didn't go 150. So you might want to, go back to your window and maybe make that like 120 for your maximum distance horizontal, and your maximum height maybe make it 50. Doesn't really matter, but then it fills up more. It just looks nicer. Okay. So then you're going to copy your window out. So x, and then just list them. Your minimum was 0. Your maximum was 120, up by tens. And then for y, it was 0, 15, up by 2s. Okay. Now h of 40. So if you have your graph, you press graph, you don't notice how it says the word state. State means you just have to give the answer. You don't have to show any algebraic work. And it's in your calculator, so use your calculator. So remember, you go to trace, and if you just punch in 40, it assumes you know that's your x value. It goes to the point where y is 9.6, which in this case is your vertical height. Okay, and that's vertical height in meters. Value for height after 70, so you're in trace. Punch in 70, it goes to x equals 70, and that's 8.4. Another thing you can also do, it takes longer, but you can go second trace, and the first thing there is value, and it will actually prompt you x equals 70. Okay, but I find it easier just to be in trace mode. And then value d such that h of d equals 3.6. So remember, that's the vertical height. So you go back to your y equals, and your vertical height is 3.6. And there's two values, right? Because the ball goes up and then comes back down. So you want to go second trace, you want to find the intersection. Okay, and so just enter, enter, enter. And in this case, it gives you the second one. So d equals, I'm going to put that like that because there's a smaller one. Now, to get the other one, you have to be closer to it. So you can go second trace, intersect again, but if you just go from there, it's always going to give you the same one. So now cursor to the left with your arrow keys till you're closer to the other one. So you got to get over the maximum there. And back on the other side. Now go enter, 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 and it's x equals 10, which is your distance equals 10. And those are meters as well. And then value d to the nearest tenth such that h of d is 7. So go to your y equals. It's not cooperating. Okay, so graph it. Go to y equals, which is not cooperating for some reason, so I'm going to do it here. Okay, and so we want to cursor down and change your Y2 to be 7. Now press graph. And you get those intersections. So second trace, and then second trace. Again, second trace, and then we want to do intersect. So you can cursor down or you can just press 5. And then we want to go enter, enter, enter. And that gives you, says to round, so 77.4 to the nearest 10. And that's the largest one. So this is D equals 77.4 meters. Then do the same. So second trace, intersect, and then cursor closer to the other one. Enter, enter, enter. And that's 22.6 meters. Okay. Example 4, this is all algebraically, so we want to substitute, okay. We want to substitute in two for every x, and really you can do it all in one step. If it says determine, that means show your work. So I'm going to show it in steps here. 4 times 3 is 12, minus 14 plus 2 is 0. Okay, here 3 times negative 4 squared minus 7 times negative 4 plus 2. That's going to be negative 4 squared is 16 times 3 is 48, plus 28 plus 2 is, that's going to be 78. Okay. Then, just another notation here, F with the brackets, sometimes you will see it like this, okay? Not in our textbook per se, but in other textbooks you might see it. And perhaps in some IB stuff, although I think they often use the function notation, but it's F colon X with an arrow, okay? So determine F of 21, still you substitute in, nothing changes. So that's going to be, so F of 21 equals 3 minus 21 minus 5. I put brackets around what I substitute in, particularly if it's negative. Okay, and that's going to be 3. Notice, oh, that's positive 21, sorry. Do this again. And so that's going to be 16, that's 3 times 4, which is 12. Okay. Next one is a rational. So I'm going to fit it in over here. That's going to be, so F of 4 is going to be 2 times 4 plus 1 over 5 times 4 minus 8, which is 8 plus 1 over 20 minus 8, which is 9 over 12, which reduces to 3/4. Okay. And last question, 6. Linear, determine F of negative 4, so 5 times negative 4. Really important to have brackets if it's negative, otherwise it might look like subtracting. So that's going to be negative 20 plus 6, which is negative 14. Now this is variables, right? It's an expression, it's not a number. So it's going to be 5 bracket 3 minus 2a plus 6. Order of operations, you need to distribute. Right, so that's going to be 15 minus 10a plus 6, and collect like terms, 21 minus 10a. Goes back from Math 9, really. Then this one here, again, is more complicated, but it just substitutes right in. So wherever there was an x, you put in the expression in the brackets. You expand that out using the distributive property. And collect like terms. And then working backwards, find x so that f of x equals negative 34. Okay, so we know that f of x is 5x plus 6. Okay, so now we just work backwards. So you want to subtract 6 from both sides. Oops, subtract 6 from that. So that's negative 40 equals 5x. Oops, 5x. Divide by 5, so x equals negative 8. Okay, and that is function notation.